remind you, when it comes to implicit differentiation, there's a difference between taking the derivative with respect to x of an x versus taking the derivative with respect to x of a y. Okay, so we're going to practice with what that difference is, because you need to remember that y's are functions of x's. Okay, and because y is a function of x, it's some kind of expression that involves an x, and therefore you are always going to have to use the chain rule where a y is involved. Okay, so if I were taking the derivative with respect to x of an x to the 4th power, what would that be? Anyone? 4x. It would be what?
4x cubed.
4x cubed, right? Power rule. 4x to the 3rd power. That's when you're taking the derivative with respect to x of an x, some kind of x. But if you were taking the derivative with respect to x of a y to the 4th power, what would that be? 4y cubed, power rule, times y prime. Because you have to understand, or you can put a dy dx. Either you write it, people write it either way. Either you put the y prime or the dy dx. But essentially, this is the chain rule portion. Because the y, if you actually looked at what y is, like in the example that we did yesterday, the y turned out to be, it was like a 1 over x minus 1. So you have to think, like if the y is really a 1 over x minus 1, when we're talking about y cubed, we're talking about a 1 over x minus 1 cubed. The derivative of a 1 over x minus 1 cubed is not just bring the 3 down in front and reduce the power by 1. You have to, yeah, you do have to bring like the 3 down in front and reduce the power by 1, but you have to follow it with the derivative of the inside function. Is everyone okay with that? That's the whole reason for this little y prime. Saying, hey, we're taking the derivative of the inside portion, which we're calling a y. Okay. What if I have the derivative with respect to x of a 6x? What is that? That was just 6. But what's the derivative with respect to x of a 6y?
6 times y prime?
6 times y prime. Exactly. Okay. So it's going to be 6 times y prime. What if I have, what's the derivative with respect to x of an x? That's a 1. What's the derivative with respect to x of a y? It's a y prime. What's the derivative with respect to x of a sine x? Cosine of x, right? What's the derivative with respect to x of a sine y? Cosine y times y prime. It's the extra chain rule that's involved whenever you're dealing with a y. Is everyone seeing the difference between differentiating with respect to x for some x thing versus some kind of y thing? Okay, it makes a difference, right? So in our problems, we have to keep in mind, because we will be talking about, we're always going to be taking the derivative with respect to x, but sometimes it'll be something involving an x and sometimes it'll be something involving a y, and you have to treat them slightly differently because the y's all need the chain rule. Okay, so yesterday though, I just want to point something out. In yesterday's function, so the example from yesterday was x, y, minus y equals 1. And I wanted to point out to you that for the problem we did yesterday, we actually looked at it 2 different ways. And we said, hey, option 1 is if you can solve for y, you can just get the y by itself. Okay, so what we did yesterday was we said, oh, maybe we can factor out the y, and you get x minus 1 equals 1. And we divide both sides by x minus 1, and we got y equals 1 over x minus 1. Hey, if your function is already solved for y and you have all the x's on the other side, no need to use implicit differentiation. You can just do a direct like quotient rule right here. Okay? But we also redid this problem where we didn't solve for y, and we did implicit differentiation on the same exact problem. the reason you need to learn implicit differentiation is option 1 is not always viable, okay? Meaning that you can't always solve for y. Yeah, in this problem example that I gave you, it was possible to actually get the y by itself, but you are going to be dealing with more complicated problems. So for example, let's say I gave you a problem like this. Excuse me. Like this. All right. So, oh my goodness, my throat. Okay, x squared minus x squared y plus xy squared plus y squared equals 1. How would you solve for y if you wanted to use option 1? Like here, we just factored out the y, right? How are you going to solve for y in this problem? You got like a y here, you got a y squared here, you got a y squared here.
Could you not factor out the squared?
Factor out which one?
The square, like the squared.
Okay, when you say factor out the square, what do you?
Never mind, I guess.
I'm not sure what square you're talking about.
I just saw like squares in all of them, but they like.
You can't pull a square out of everything. But if I didn't want to do implicit differentiation, I would have to be able to get the y by itself. Has to look something like this. I'm going to say it's going to be pretty hard, if not impossible, to get that y by itself. Kellen, you have a suggestion.
Is that x minus y times x minus y? Factored it?
No. Okay, so basically, you can't actually solve for y. So that we don't have any choice. In a problem like this, we're going to have to basically differentiate with the equation as is. Okay, so we must do implicit differentiation. So that means I'm taking the derivative with respect to x of this whole equation as written. All right, so this is what? X squared minus x squared y plus xy squared plus y squared equals 1. And term by term, I have to take the derivative with respect to x. So, starting with the first term, what's the derivative with respect to x of an x squared? 2x, okay, perfect. Then I have a minus sign, correct? Well, after the minus sign, the next thing I come upon is this x squared y. If you want to take the derivative with respect to x of an x squared y, won't you need to do some kind of product rule? Because this is some kind of product, right? So, using my product rule, and I'll put parentheses here because I'm going to put my little product rule in here, my fg prime plus f prime g, okay? So, first times derivative of second, fg prime. So, f is just the x squared. Is everyone okay with that? But then the g prime means the derivative with respect to x of a y. What's the derivative with respect to x of a y? Y prime. Okay, so that's your fg prime plus your f prime, meaning the derivative with respect to x of an x squared? 2x. That's the f prime times the g. But the g is just y. Now, is everyone okay with what's written in red? And why we did that product rule? Okay. Okay, so moving on. Then I come across a plus sign, right? Next thing is a plus sign. And then I have to take the derivative with respect to x of the next term, but the next term is an xy squared. Well, isn't that another product rule right there? Right? Product of two functions. So here's going to be my next product rule. And I'm going to do another fg prime plus f prime g. So first function is just the x, that's your f. And then I have a g prime, but that means I have to take the derivative with respect to x of a y squared. What's the derivative with respect to x of a y squared?
2y.
2y
Y prime.
times y prime. Chain rule on that, right? Okay, so that's your f, where am I? Fg prime plus the f prime g. So my f prime would be the derivative with respect to x of an x. So 1. Okay, that's f prime times my g, and my g is just y squared. Is everyone okay with that? Okay, then I move on. The next term is a y squared. So I just want a plus, I want the derivative with respect to x of a y squared, 2y times y prime. Everyone okay with that? Then I hit my equal to sign. And then on the right hand side I have the derivative with respect to x of a 1, which is 0. Derivative of a constant is 0. All right, so here's where I've done my initial derivative. This is doing an implicit differentiation, meaning that we are differentiating as is with all the x's and y's mixed up, okay, using a chain rule wherever the y was involved. Now, I still have to actually solve for y prime. That's what I want. What is y prime? What is dy dx? So to get the y prime by itself, first I better get rid of these parentheses. And when I look at this, I see this minus sign which can be distributed into that parentheses. And this second parentheses, that's just a plus sign, so I can just drop that second parentheses. Okay, so distributing this minus sign here, I'm gonna get, what is that, 2x minus x squared y prime minus 2xy plus this blue one. Let me just rearrange the terms. I kind of like my numbers out front and not in the middle, so that x2y y prime, I'm gonna rewrite as 2xy y prime. Just put the number out front. Okay, but it's the same expression. Plus this 1y squared is just a y squared. Okay, and this is a plus 2y y prime equals 0. Any questions up through here? Everyone's okay? So if you're trying to solve for y prime, you want to find all the terms that have a y prime in them, okay? To get the y prime by itself, you need to have all the terms with y prime in them on the same side of the equal sign and everything else on the other side. Because if you can collect all the terms with a y prime on the same side of the equal sign, then you can factor out that y prime and divide. Okay, that's how you're going to get your y prime by itself. So everything I've underlined in red has a y prime in it, and the other things don't have a y prime in it. So I'm going to move those other things and subtract them over to the right hand side. Is everyone okay with that? Okay, so that's going to give me, let's see, a minus x squared y prime plus the 2xy y prime plus the 2y y prime. Those are all the things that had the y primes in it, and I'm moving everything else to the other side. So this 2x subtracted over becomes a minus 2x. The minus 2xy added to the other side becomes a plus 2xy. And this y squared on the left-hand side subtracted to the right-hand side becomes a minus y squared. Any questions on that? Everyone's okay? Now you can factor out your y prime. Okay, so you've got a y prime in each one of these terms. You can factor it out. If you factor it out, what do you have? You have, yep.
Plus 2xy plus 2y.
Right, everything that's left once you pull the y prime out. Here's the right hand side. Like that. And your last step is really just to divide to get that y prime by itself, right? So if you divide both sides by what's in the parentheses, by the minus x squared plus 2xy plus 2y, divide both sides by the minus x squared plus 2xy plus 2y, this in parentheses is going to cancel, and you basically end up with your y prime is this fraction that's over here. Okay? Did everyone see how we did that, or is there a question on that? No question on that? Everyone's good on that? All right. Then, let me add a second question. What if I then ask you, so we just found out what y prime was. It's what's boxed off in green over there. So part 2 of this question is if I ask you to find, continuing with that same example, I now ask you to find the slope of the tangent line to the curve x squared minus x squared y plus xy squared plus y squared equals 1 at the point 1, 0. Okay, so the first part of the problem was just find out what y prime is. What is dy dx? And one thing you'll always notice is when you are doing implicit differentiation, your derivative will end up being in terms of x and y. Basically, your derivative has x's and y's mixed up in them rather than only x's. Okay, so all the x's and y's are mixed up here. If you're being asked for the slope of the tangent line to the curve, and by the way, this curve is the same curve that's written on that on the right-hand side board. We want the slope of the tangent line at the point 1, 0. How do you find slopes of tangent lines? What are you supposed to do? How do you find the slope of a tangent line? Plug in the 1 into the derivative. And you're going to have to not only plug in the 1, because remember what your derivative looks like. You have to plug in both the 1 and the 0, right? Because your derivative has x's and y's in them. You have to use both the x and the y value when you're computing the derivative. So we already know what our formula for the derivative looks like. It's this formula right here. I guess I'll write it over here since it's easier to copy over here. Our derivative we already found out was this minus 2x plus 2xy minus y squared over the minus x squared plus 2xy plus 2y. That's our derivative. Now you have to evaluate the derivative at the point that we asked about, at the point 1, 0. Meaning you're going to let the x be 1 and the y be 0. Is everyone okay with that? So this will end up looking like you just pop in, replace all the x's with 1s, replace all the y's with 0s, and you get minus, what is this, 1 squared plus 2 times 1 times 0 plus 2 times 0. What is that going to give us?
I got negative 2 over 1. I thought
Negative 2 over, well that's 0, that's 0, that's 0, that's 0. The top is a negative 2, what's the bottom? Not a
Negative. It's 2. The answer is 2.
What's the bottom is my question.
Negative.
-1. Because that's a negative in front of the x squared, right? You've squared the 1, but there's a negative sign in front of it. So that's a -1, and therefore you're getting negative 2 over -1, which is 2, okay? That is the slope of your tangent line. If I wanted the equation of the tangent line, well, if I want the equation of the tangent line, now that I know the slope, I could do like a y minus y1 equals m times x minus x1. Is everyone okay with this? We can ask all the same questions we asked before. Find the slope of the tangent line, write the equation of the tangent line, right? It's just that to find that slope, you might need to do an implicit differentiation rather than a straight out product rule, quotient rule type thing, okay? So, is everyone okay? What would we write here if we wanted the actual equation of the tangent line?
Y minus 0 equals 2x minus 1.
Done. Right? We popped in our x1, y1, and we popped in our slope that we found. Does that make sense to everyone? Or is there a question on that? Okay. You got a whole bunch of problems on this worksheet, 3.8. The first one is just a straight differentiate the expression with respect to x. You're just going to do a product rule on that. Is everyone okay with that? The x squared y cubed. Product rule, and you're not even solving for anything. Just do the product rule and stop, okay? In problem 2, yes, you're going to do the implicit differentiation, and yeah, maybe there's product rules built in to the problem, but if you are calculating the derivative of y with respect to x, in other words, you're calculating y prime, you will, after you take the derivative, have to go through the steps and get the y prime by itself. Okay, you do not need to get the y prime by itself for problem number 1. You're just doing product rule and just leave the expression. Okay, so could you please get into groups and work on this worksheet?
Right, let's just do
Your
it.
answers are going to be pretty big.
Will that be due today?
No.